Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 7th video in the Introductory Programming in Java full course. In prior videos, we looked at Java input processing output programs. We've talked in detail about input and output, and we've gotten a start on processing by talking about text and numeric data types, variables, and assignment statements. Now we'll focus on expressions, what we can put on the right side of an assignment statement or any other place that Java expects a value. Let's get right into it. Let's begin by defining an expression. Here's the definition from the Oracle Java tutorials. An expression is a construct made up of variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. Now, if we look at the grammar for Java, an expression is more complicated than this, and there's one thing in particular that's missing from this tutorial definition that's in the grammar that I think should be there, literals. So I'd rephrase that as, an expression is a construct made up of literals, variables, operators, and method invocations, which are constructed according to the syntax of the language that evaluates to a single value. And that's a mouthful, sure. We're going to look at examples and talk about what the different parts of that definition mean so the whole thing makes sense. Here's our moon weight age calculator program from an earlier video. In this program, we have 3 assignment statements at the top on lines 17, 18, and 19 that all assign a literal to a constant. This is why I wanted to include literals in the definition. Literals are the simplest expression. The literals in our program, 9.81, 1.622, and 13.52 are very simple expressions because, as you know, literals evaluate to literally what you see. 9.81 is an expression that evaluates to 9.81. As you also know, 9.81 is a literal of the double data type, and so it can only appear in a Java program anywhere it is syntactically appropriate for a double to appear. The definition has that phrase, which are constructed according to the syntax of the language. Our programs always have to be syntactically correct, and the syntax is something you have to learn, but it isn't trivial. It reflects an underlying meaning. You've probably seen the joke, let's eat grandma versus let's eat grandma, and then it says something like, grammar saves lives. The comma fundamentally changes the meaning of that sentence. Are we inviting grandma to eat with us, or are we suggesting grandma is the meal? Not all syntax is equally important in natural language, but it's all important in programming because if Java can understand it, it will change the way Java runs your code. The wrong syntax can change your program from something that works correctly to something that doesn't. Now, the definition says expressions can be made up of variables, operators, and method invocations. We have examples of expressions made up of variables and operators on lines 36 and 37, and we have expressions made up of method invocations on lines 30 and 32. Let's start with the expression on line 36, where we're calculating the moon weight. This expression is a direct Java translation of a formula. To calculate your weight on the moon, divide your weight on the Earth by Earth's gravity, and then multiply that by the moon's gravity. That translates to Earth weight divided by Earth gravity times moon gravity. We're not using literals here like you might if you were calculating this for yourself with a calculator. Programs are usually general, relying on variables so that the calculation can be done with different values, whatever value the variable holds at a given time. So how does that work? Each variable is itself a simple expression. The variable evaluates to whatever value was last assigned to it. Earth weight got a value on line 30. So on line 36, the expression earth weight is evaluated, and that will be a double version of whatever the user typed when prompted for their weight. And then the expressions Earth gravity and moon gravity are evaluated to the literals they were associated with up in the constant section, and then the expressions that are formed by those values combined with the division and multiplication operators are evaluated. So if the user typed 100 when they ran the program, and 100 is stored in Earth weight, the expression becomes 100 divided by 9.81 times 1.622, and then the expression is evaluated according to order of operations. So 100 divided by 9.81 evaluates to 10.19 and change, and 10.19 times 1.622 evaluates to 16.53, etc. And now we're down to a value, and that is the value of the expression. That is then assigned to the variable moon weight. When expressions are made up of variables, constants, literals, and operators, the literals evaluate to what they literally are, the variables and constants evaluate to the last value assigned to them, and then the operations are carried out according to order of operations. We'll look at the operators available in Java and order of operations in the next video. Here, I just want us to establish what an expression is. The definition of an expression says it can include method invocations. What is that? A method is sometimes called a subroutine or function or procedure. It's a block of code that we can invoke or call or tell to execute. In Java, a block of code that we can invoke is called a method. We've been invoking methods a lot because we have to use some pre-written code to get input from the console and produce output. So we call print, println, and next double, next int, and next line. Of those, only next int, next double, and next line evaluate to a value. So those are the only method invocations that can be part of an expression that evaluates to a value. On line 30, where we invoke next double, that invocation, standardin.nextDouble, is an expression because it evaluates to a value, the value that the user typed converted to a double. Let's look at a different sort of method invocation we can include in an expression. Think about the formula to calculate the hypotenuse of a right triangle. If the sides are a and b, the formula is the square root of a squared plus b squared. We know how to multiply, but how do you raise a number to a power, and how do you take a square root? You might have noticed that when you type a program, you type it in a text editor on a standard keyboard, and there's no way to include fancy symbols like you can with the equation editor in Microsoft Word, for example. There's no way to include a radical or a superscript. So to get some fancier mathematical operations, we need to turn to the math class. Here is Oracle's documentation, and if we scroll, first you can see there are a lot of operations here, but we find POW, which allows us to raise a number to a power, and SQRT, which allows us to take a square root. You can use any of these, of course, so it's worth going through the page and seeing what's available. I'll include a link in the description. Look at square root. On the left, it says static double. The static means that we are going to use the name of the class, math, to call this method. When we use the scanner, we create an instance of the scanner. We write standard in equals new scanner system in. And then to use the methods, we use the instance variable, standard in. But here, we won't use the new keyword. We'll just prepend square root with math. The double means it returns or evaluates to a double. That means we'll put our call to square root anywhere we can put a double in a Java program. On the right, it shows us the name of the method, square root, and that it takes one parameter, a double, and it returns the correctly rounded positive square root of a double value. Another thing to note, at the top of the documentation for math, is that it's in the java.lang package. That means we don't have to import math to use it in our program because it will be imported automatically by the Java runtime environment. I'm going to create a new class. So I'll right-click on our default package and choose New Class, and I'll make sure there's no package, and in the name, I'll call this hypotenuse. Check the public static void main string args box and click Finish. Let's delete the to-do comment and define 3 double variables A, B, and C. Normally, those would be pretty terrible names for variables, but we're using the C equals square root of A squared plus B squared formula, and there's no other context, so the formula is the context. We'll import java.util.scanner, create one, prompt for A and B, and read those in with our scanner using next double. Okay, now we want to assign the result of the square root of A squared plus B squared to C. The square root of A squared plus B squared will be our expression. I'll write C equals, and then math.square-root, open, close parentheses. Inside the parentheses, I must put the value I want to take the square root of. That can itself be an expression, as long as it evaluates to a value that we can pass to math.square-root. Math.square-root, as we saw, takes a double. Inside the parentheses, let me square A by writing math.pow, and in parentheses, a, the base, and 2, the exponent. And I'll add that with plus Math.pow, and in parentheses, b for the base and 2 for the exponent. And let's just print C to make this quick. Let's run it with 3 and 4 for A and B, as in a 3, 4, 5 triangle, and see if we get something like 5 as the output. And we do. So how is that expression working? A method call has a high precedence, and we must evaluate the arguments to a method call before we can call the method. So we evaluate inside out, basically. Math.pow A2, and then Math.pow B2, and the results of those are added together, and then that result is sent to Math.sqrt. And once that evaluates to a value, it is assigned to C. So there is your introduction to arithmetic expressions in Java from the definition of an expression. In the next video, we'll dig into arithmetic operations a little more, including the modulus operation, the remainder of an integer division, and order of operations. I've got an auto-graded exercise in the description of this video to help you practice with this. Click on the link, and you'll go to an exercise that allows you to practice with the hypotenuse code. If you get stuck, come back and watch the video. I'll also upload the code to my GitHub repository, and there will be a link in the description. The best practice is to write this program from scratch in Eclipse and then make some changes to it. For example, you could assign the results of Math.pow to 2 different variables, maybe called a squared and b squared, and then invoke Math.sqrt using those variables. Try some of the other operations in the math class. When you're feeling confident writing arithmetic expressions that include literals, variables, the math operators, and method calls, come back for more with the next video. As always, have fun and keep coding.